Hi there. Today we'll look at Inconsistency in Conference Peer Review, revisiting the 2014 NeurIPS experiment by Corina Cortez and Neil D. Lawrence, which were actually the chairs of the 2014 NeurIPS conference. So they are going to have access to some data that the rest of us sadly don't have access to. But also it allows them to make pretty cool research on how conference reviewing works and whether or not it actually can determine the quality of a paper or how much of it is just random subjective reviewer decisions. Now, this paper particularly here takes up the papers that were subject to the 2014 NeurIPS experiment and tracks them over time. So it looks at the papers that were submitted, how did they perform in the subsequent years, meaning how many citations that they accumulate, both for the accepted and for the rejected papers. And they find some pretty interesting results right here. So we'll dive into this. The paper is not too long and the conclusions are fairly straightforward. I still think it's really cool that people actually follow up on this work. So for those of you who don't know, the 2014 NeurIPS experiment, that is the wrong color, the 2014 NeurIPS experiment was an experiment in assessing how much of conference review is random, essentially. So what you did was, and I think they have a little section about this here, yeah. So they selected about 10% of the submissions. These were 170 papers. And these would undergo review by two separate committees. So whereas usually you have a paper that goes into a review, let's call that a committee, which is a bunch of reviewers and an area chair, and they make the decisions of whether to accept or to reject. And yeah, at the end you have a decision. So in this experiment, you would take a paper, you would actually give it to two different committees, Committee 1 and Committee 2. Committee 1 would only be selected from kind of one half of the reviewer pool, and Committee 2 would only be selected from the other half. These were random assignments and to the two pools, and also the papers who participated were randomly selected. So each of these committees would reach their own decision, accept or reject. And of course, the interesting part is how many of those agree or how many of those disagree with each other. And by the way, the paper would be accepted finally if the max, so if either of the committees would accept the paper. And if I recall correctly, this year's NeurIPS conference actually repeats that experiment from 2014. So we're going to have another data point in hopefully assessing how conference reviewing has developed over the years, whether it's gotten better or actually worse. All right, so that was the experiment in 2014, but by the way, the authors here have decided that the name change is retroactive. I never know when talking about old NeurIPS conferences whether I'm supposed to say it was NIPS 2014 or NeurIPS. In any case, in this paper, we're doing NeurIPS. So what was the outcome of that experiment? And that's pretty interesting. Namely, here you can see these are still 2014 numbers. Committee 1 and Committee 2 split up. So it's not the same Committee 1, of course, but Committee 1 would always be reviewers selected from kind of the first half of the population, Committee 2 from the second half. They did agree on most of the papers, as you can see here. For 101 papers, they agreed to reject. For 22, they agreed to accept. However, for 43 of the papers, one committee would accept and the other one would actually reject. So for about 25% of the papers, the two committees would disagree. 25%, it's a lot, but it doesn't sound like that much. But if you look at it in a different way, where they say right here, if the conference reviewing had been run with a different committee, only half of the papers presented at the conference would have been the same. So this is looking at, if you'd, for example, always go with Committee 1, you would have these papers. But if you would always go with Committee 2, you would have these papers. Therefore, but the simple selection of the committee determines about half the papers at the conference. So if you're at the conference, you walk through the big halls of posters, or you look at the proceedings, you have to keep in mind that half of the papers are there only purely because of the random choice of, or not purely, but they wouldn't be there had the reviewing committee been a different one. Half the papers. That's kind of crazy. And of course, this sparked a lot of discussion right here. So this is the outset. This was the results from that time. And now we're going into new analysis. So they do 3 different distinct points of analyses. The first one is they do, the title is called reviewer calibration. So they try to figure out what portion of a reviewer's assessment of a paper is, let's say, objective, and what portion is subjective. So what portion of a score is simply due to the reviewer's subjective feelings about the paper that doesn't match with any other reviewer's scores. So here you can see this. For example, what you can do is you can build a model. You can build a model and you can say Yij, that's the score that the jth reviewer gives to the ith paper. Right? And being the conference chairs, these authors here would have prime access to that data. So what you observe is Y. Now you can say, we assume this is a combination of 3 things. First of all, we assume that there is some sort of a objective paper quality, which is Fi. This is the objective quality of the paper. This is actually what the reviewers are trying to predict. So when the reviewer posts the number Y into the system, they're trying their best to actually assess Fi. However, there is also this Bj right here, and this is the bias that the jth reviewer has in calibration. So not everyone sees the 1 through 10 or 1 through 9 scale that we have in the same fashion, and therefore what's like a 3 to me might be a 5 to you. So we have to correct somehow for this, and the inclusion of this Bj factor is how we account for that. And then lastly, you have this Eij factor right here. And this is the subjective portion of the score. So this is independent of the objective quality of the paper. This is sort of the subjective bonus or penalty that reviewer J gives to paper I. And our goal is going to be to figure out how do these 2 numbers compare to each other? How much of the score is objective versus subjective after we have calibrated for reviewer, for general reviewer bias, for calibration bias, let's say. Keep in mind, this is a model. This is how we imagine the world. All we observe is this Y thing right here. What we can do is, of course, we can put up a linear system of all the scores, right? And of all the scores, because every reviewer does give more than 1 score in this conference, and every paper gets more than 1 reviewer's scores. So we can put up a linear system, but it turns out this is over-parameterized because you only have as many numbers as you have these parameters right here. So the rest, both parameters, you don't have enough data points to assess that. Now, as much fun as over-parameterized models are in deep learning, they're actually not that good if you want to estimate a linear system. So what people do, they come up with regularizers and Bayesian approaches and yada, yada, yada. I'll skip all of this to just give you the numbers. So the model that these authors come up with determines that the factors of the linear systems are as follows. This here is the factor that goes with the Fi. This one is the one that goes with the Bj, and this one is the one that goes with the Eij. And you see, you pull out this one, and then you simply compare the number on the left to the number on the right, and you'll see they're almost exactly the same. And that means, and they formulate this here, In other words, 50% of a typical reviewer's score is coming from opinion that is particular to that reviewer and not shared with the other reviewers. This figure may seem large, sorry about that. This figure may seem large, they say, but in retrospect, it's perhaps not surprising. So this is pretty, I guess this is pretty surprising to me, but it is not that I didn't expect it. And I think anyone who's participated in conference peer review would expect a number that is in approximately this range, because we know that the review process is pretty noisy, and very, very often individual reviewers just kind of give weird scores that you don't understand. And here's the reason. You don't understand because it's the source of them are subjective and largely not shared by other reviewers. So having figured out that about 50% of the variation is due to just subjective feeling of a reviewer about a paper, now they sort of try to validate their findings. And for that, they run a simulation. So the simulation is, it's a simulated conference. So we assume that each paper was scored according to the model we've given above, and we estimated the accept consistency through averaging across 100,000 samples. So now they're simulating the conference with this experiment done, and they ask themselves, if this is really the correct model, then we should get back a consistency of the 50% we found above, right? So because above, the results of the experiments were that there was about a 50% consistency in acceptance in the experiment. And now they go and they look at all the papers and all the scores, and they determine that there is about a 50% subjectivity in scoring. And now they ask themselves, do these two numbers match? And they run a simulation where every reviewer has a 50% subjectivity. And they ask themselves, if we simulate this splitting up into two committees, and then every committee agrees by themselves, do we see the numbers that we found in the experiment? And the answer is yes, actually. So you can see these are conferences for a bunch of different scenarios, namely for different number of reviewers, as you can see here. These are reviewers per committee. So random means there is no reviewer per committee. Committee decisions are just random. And you can see that as the accept rate of the conference goes up, the accept precision of the committees go up, because more papers are accepted, and therefore more papers would be the same if you were to change the committee. What we're interested in is, of course, the one with 3 reviewers, which is the most common reviewer scenario in these conferences, and that's this curve right here. So the way to read this is that, for example, if the conference had an accept rate of 50% right here, then we would expect a reviewer consistency or an accept precision of 0.75 of 75%, which means that if we were to switch the reviewers for a particular or for all the papers, 75% of the paper would still be the same. Remember that in our experiment, only 50% of the papers were still the same if we switched committee. But the conference also didn't have a 50% accept rate. So for that, we actually need to go to the accept rate of the conference, which was something like 23% right here. And then if we look that up, we are at about a 60% accept precision. Now, this might still be away from the 50% we found in the experiment. However, the experiment had so little data that if you calculate the bounds on what the true accept precision was from that experiment, you can determine that it was between 38 and 64%. and the exact number we got is 61%. So this is still within the bounds of what we found in the experiment. So pretty interesting. This actually means that the model they put up is a close enough approximation to reality such that it predicts the experiment's outcome. And this gives us a little bit of validation that we're on a good track right here. So we can sort of confidently say that about half of a reviewer's decision on a particular paper essentially comes down to subjectivity. It's consistent with what we found in the experiment, and it'd be interesting to see how this develops this year when we repeat the experiment. So lastly, what they were trying to figure out is, well, are these reviews even worth it, so to say? Do they actually predict how good a paper is? And, how do you measure how good a paper is? Of course, by the number of citations. So here they define the citation impact as the log of the number of citations. And yes, there is a debate about whether citations really mean a paper is good or influential or blah, blah, blah. But we don't, for better or worse, we don't have a different measure right now than number of citations. And it's been 7 years, which is like 3 generations in machine learning. So there is a long enough time that these papers had to accumulate citations. So let's just look at the accepted papers. Do the scores that the reviewers give to the papers predict in any way whether or not the paper is going to be cited more or less? So do higher scores indicate more citations? And the answer is no, not at all. So here is a plot. The correlation is 0.05. This is ever so slightly statistically significant, but not really. You can, at least for this particular conference right here, there's no correlation between reviewer scores and impact of the paper in the future. It becomes a little bit interesting when you ask specifically. Because here the question is, is the paper novel? Is it correct? Is it well written, and so on? These are not necessarily indicators of significance, right? If you accept the paper to a conference, only a small part of it is it significant. If you actually ask reviewers, do you think this paper will have a potentially major impact or not, you get a slightly higher correlation, but also not really, which means that reviewers are kind of bad at estimating whether any given paper will have a big impact or not. Though to be fair, for most papers, the answer is probably no by default. However, the interesting part is when you ask them about their confidence in their rating. And it is, if I understand correctly, it doesn't even matter which rating. But for the rating that you give at these conferences, you have to provide a confidence score. Like you say, okay, I think this paper is really good, but I'm not very confident. And if you simply correlate the confidence scores, as you can see here, the average confidence over all your sort of confidences of the paper with the impact, then you do get a slight correlation, which is interesting, right? So the authors here argue that it might be that there might be something like clarity in the paper. So if a paper is written very clearly, then you will also be able to understand it better as a reviewer, which makes your confidence higher. But also, since the paper is more clear, it means that the rest of the world will have an easier time understanding the paper and therefore cite it more often. So this is a good hypothesis, but it's quite interesting that that the confidence in papers it seems to predict the impact better than the actual assessment of the impact. That's astounding. It's not super astounding that confidence by itself would predict it, but that it does so more than if you directly ask people. I wonder what else we can ask. Like, I wonder what weird questions we can ask that will then up correlating with the future impact. Like, do you like the colors of the paper? Do you like the pictures? So these were for accepted papers. They also interestingly trace the fate of the rejected papers. So they say only 414 were presented at the final conference. So they want to trace the rejected papers, and they go through a lot of work to try to figure out where these papers ended up. So they search for papers with similar titles and authors, or same titles and authors. And of course, this is not a perfect process, but it seems like they've been able to trace a lot of these papers to their final destination. You can see a lot of papers are discarded, or some are simply posted on archive or somewhere else. Of course, the discarded papers, you don't know if they somehow morphed into other papers or something like this. But it's still pretty interesting to see, though they say there are various error sources in these plots. Lastly, here is the fate of the rejected papers. Now, they don't say exactly what blue and green means in this particular thing. In other plots in the same papers, they differentiate, for example, between papers that have been accepted somewhere else ultimately and papers that have not been, or that they have not been able to trace. So this might be blue and green. I'm not sure. I haven't been able to, maybe I'm just stupid at reading. But as you can see, if you look at the rejected papers, so this is the calibrated quality score for the rejected papers. And here you can see that there is, in fact, a correlation, which means that for the rejected papers, the assessment of the reviewers really does correlate with how the papers will end up doing ultimately. Though I'm going to guess, well, if the citation count is in here, I'm going to guess the discarded paper must not be in here. Sorry. But the conclusion is that for the rejected papers, reviewers can tell whether they're better or worse. For the accepted papers, not so much. And that's what they said at the beginning. The review process is probably good at identifying bad papers, but bad at identifying good papers. And it's not too surprising, because bad papers, you can find, it's really easy to recognize a very poor paper. But it's harder to recognize really how good a paper is, compared to other good papers. So that was the paper. They give some recommendations. For example, they say, well, maybe we should assess papers on different criteria than we do now, but they do warn against saying we should do away with subjectivity altogether, because as annoying as the subjectivity is, they argue, it also guards against sort of the collective dominance. So it guards against sort of making consistent mistakes. So if the entire conference, if the entire conference makes consistent mistakes in some direction, then the subjectivity might counter that a little bit. I'm not sure if that's a super good argument. I am generally for noisy processes over super duper rigid ones. It seems though that the conference review right now is a bit too noisy. I'd rather do away with just having 3 reviewers and not having this accept barrier. This is my personal opinion. I would just do away with the accept barrier altogether. You submit to a conference, you get a bunch of scores, and then you have the scores. Like, why do we need to divide papers up into accepted and rejected? Or, it seems better to just put papers out there and let let the future researchers assess them in retrospect, rather than having 3 random people with highly subjective opinions assess them. But yes, probably a bit of noise is good in a process like this, if you do a process like this. They also say, well, maybe we should not put that much value at publishing at top tier conferences. Now, I don't know how that's gonna work, like whenever and yeah, I wish as well that we could like change the collective thinking about our field. I don't see that as a super easy task though. In any case, this was the paper. Let me know your ideas. Let me know how you think this year's experiment is going to turn out. Like, are we going to find more subjectivity? Are we going to find less? How much disagreement do you think we're going to find? This is going to be interesting. So yeah, thanks for listening, and I'll see you next time.